Okay, today we're going to look at scale models and scale factor. It says here on page 308 of the blue textbook, this HO gauge model train is a scale model of a historic train. A scale model is a proportional three-dimensional model of an object. Its dimensions are related to the dimensions of the actual object by a ratio called the scale factor. The HO scale factor is 1 to 87. This means that each dimension of the model is 1/87th of the corresponding dimension of the actual train. A scale is the ratio between two sets of measurements. Scales can use the same units or different units. The photograph shows a scale drawing of a model train. A scale drawing is a proportional two-dimensional drawing of an object. Both scale drawings and scale models can be smaller or larger than the object they represent. So let's talk about that for a second. A scale model is a three-dimensional model of something. So think about it. You have this huge train, and you want to be able to have it as either, a electric train or even just a model train to sit on your shelf. You need to shrink it down, but you want it to look as much like the original as possible. So what they do is they go in and they measure everything on this train, and they shrink it down by the same amount. So in this case, they shrink it down by dividing it all by 87. And so they take the original measurement, divide it by 87, and that's the new measurement. And they do that for the entire train. And they build those pieces and parts and put it together based on that scale factor. You oftentimes, if you go to a toy store and you buy a model of something, you will see on the side of it a scale of some kind. It'll say like 1 to 64 or 1 to 24. They do this with NASCAR race cars too, model cars. They're actually shrunk down. Even the little matchbox-sized cars are considered to be scale models of the original. So that's what a scale factor is. Now, a scale is more used for two-dimensional things like maps and drawings and pictures and paintings that get shrunk down. So like if I go to the copy machine and I take a picture of something and I shrink it down to make it smaller, it's doing that by a scale because everything is proportionally shrunk down. So you have a scale. So a scale drawing is a smaller or larger representation of the original. A scale model is a smaller or larger representation of the original, but in three dimensions. And no, you don't have to just get smaller. You can get bigger. Think about it. Looking under a microscope at cells, if we see a cell under a microscope, it's teeny tiny. Well, we could actually make that cell into something bigger, and you would do a scale factor that way, except the top number would be larger than the bottom number. Okay, let's take a look here at example number 1. We are going to compare a race car to its model. And when we do this, we want to put the model on top. So it's going to be like our Y number. And we're going to put the actual on the bottom. So model over actual. So in this case, model is a model, race car, and the actual is the car itself. And we're going to put length on our first ratio. So the length of the car in the model says 11, and the actual length is 132. Then we're going to look at the width, or the height, excuse me. The height of the model says 5.5, and the height of the original, or the actual, is 66. So when I look at that, I'm going to ask myself, okay, how do I reduce those? Well, 11 will divide equally into 132, and it happens to go in 12 times. So that is 1/12. 5.5 goes into 66 equally as well, 1/12. So our scale factor here our SF, scale factor, is 1 to 12. So we just set up the ratios and reduce them. Preferably, we want the top number to be 1, but it doesn't have to be. That's the other thing. It does not have to be 1, but we do not want decimals in our scale factors. Let's take a look at using scale factors to find unknown lengths. It says a photograph of Vincent van Gogh's painting, Still Life with Irises against a yellow background has dimensions of 6.13 centimeters and 4.90 centimeters. The scale factor is 1 to 15. Find the size of the actual painting to the nearest tenth of a centimeter. Well, okay, so this is a photograph of it. And it says that the photograph of Van Gogh's Still Life with Irises against a yellow background has dimensions of 6.13 centimeters. That would be the length or the long side. So I'm going to write 6.13 centimeters over here by 4.90 centimeters. So 4.9, I really don't need that 0, centimeters is the width. And then it says the scale factor is 1 to 15. Well, let's remember the scale factor of 1 to 15. Remember what I said before, it is model over actual. And this is important because when we set up proportions, remember we want to have same things on top, same things on the bottom. Situation 1 on the left, situation 2 on the right. Well, situation 1 here is going to be our scale factor. It is 1 to 15, and it has model on top and actual on the bottom. We're going to need to take each one of these measurements that they gave us and change them back to their original. So if I wanted to change this, our model, the picture, back to its original, where would I place the 6.13 centimeters for the length? Well, since this is our model, the picture, I need to put the 6.13 on top. We are looking for the actual. Let's put an L for that because we're looking for the length of the picture. So we have a proportion that we can solve to find our missing length or our original length. So we cross multiply 1L, which is just L, and then 15 times 6.13. So I'm going to pull out my handy dandy calculator and I'm going to multiply 6.13 times 15 and I get 91.95 centimeters. So the length of the original painting, Still Life with Irises, is 91.95 centimeters tall or long. Now, that doesn't help me though with the width. I need to know the width of this painting. So what I'm going to have to do is I'm going to have to use another proportion, a second proportion. The thing is, the scale factor doesn't change. It's still 1 to 15, and it's still model over actual. So when I go to do this second proportion, my 4.9 centimeters is the measurement on the picture. So it's the measurement on the model. So I'm going to put 4.9 on top, and I'm going to put W for width on the bottom. And just like before, I'm going to cross multiply that. 1 times W is just W. And then we get 15 times 4.9. And I take and I multiply my 15 times 4.9, and that equals 73.5 centimeters. And I just realized, hey, I made a little error back here. I didn't write in what I did to get this 91.95. So I'm going to scratch that off here a little bit, and I'm going to go back and write that in. So set up proportions, making sure that you put model on top, actual on the bottom, your scale factor on the left, and then either your length or your width, and you have to do them separately. You have to do two proportions. You have to do two math problems to answer one question, but it's necessary on these where you are given the scale factor in either the original measurements or the model measurements, and you have to find the other. Take a look at example number 3 on page 309 of the blue books. It says, on a map of Florida, the distance between Hialeah and Tampa is 10.5 centimeters. What is the actual distance, D, between the cities if the map scale is 3 centimeters equals 80 miles? Okay, well, a map scale is just, it's just like a scale factor. So I'm going to put scale here and put 3 centimeters over 80 miles. So it's just like a scale factor, except it does have units of measure. Now it says on the map between Hialeah and Tampa is 10.5 centimeters. Is the map our model or is it our actual? Well, the map is the model and the actual is real life distance. So the 10.5 centimeters is the map or the model. So it needs to go on top of my proportion. And the actual distance, D, will go on the bottom. So again, we need to solve the proportion. And so you would write 3D as you cross multiply is equal to 10.5 times 80. And then you would need to divide both sides by 3 to get D by itself. The 3's will cross out. And then 10.5 times 80 divided by 3 equals 280 miles. Okay? So just to make sure our answer makes sense, because we should do that, 3 centimeters is 80 miles. So if we had 6 centimeters, that's twice as much as 3. That would be twice as much as 80. So that would be 160 miles. Down here in our problem, it's 10.5 centimeters. And so 10.5 centimeters equals 280 miles. Is that a reasonable answer? I would say yes, it is. So we can be confident in our answer. So remember, when you're doing these word problems, make sure your answer makes sense. When you're doing these proportions, make sure your answer makes sense. And make sure you're putting the model over the actual. The model could be a drawing, a picture, a photograph. It could be a model of something over the actual. The actual could be real distance like it is here on this map, or it could be a real airplane. It could be a real race car. It could be a real train. It could be a real painting. It could be a real, insect that you made a larger model of. So actual goes on the bottom, the model goes on the top.